So today we're looking at percent increase and percent decrease. And problems related to percent increase and percent decrease are really just answering this question. How much did it change? And when we talk about how much did it change, we want to answer that question in the form of a percent. So let's look at an example. We're going to start with percent increase. So here's my example. It says in January, Valerie had $100 in her savings account. In August, her savings account balance was $170. By what percent did Valerie's savings account balance increase? So it looks like Valerie added a little bit of money to her account during the year, actually a good amount of money. I want to go through and label some of my important numbers. First, let's pay attention to the number 100. This is our original amount. I'm going to write original. You might even want to just write an O. But what this means is that this is the money that Valerie started with. Next, I'm going to highlight her new amount. So this is what she has now, and that's new. And we want to know by what percent did her balance increase. So here's what we're going to do. We're going to find the change in her balance, and we're going to write that over her original amount. And then we're going to use a proportion to find what percentage that is. So that's going to be a percent, which is really just a ratio out of 100, right? So this is sort of the proportion that we're going to use whenever we're doing percent of change, which could be an increase or a decrease. We're going to have the change divided by the original amount equals the percent divided by 100. So once again, we're using proportions. All right, so how much did her balance change? Well, let's calculate it. So the change is equal to 170 minus 100. In other words, $70. In this case, an increase. We had an increase of $70 in her bank account. So I'm going to write that down, 70. And now what number should go in the denominator? Should I use 100 or 170? 100, because that's the original amount that I started with. And hey, this is going to be an easy proportion. I like that. Let me write an X here, and then my 100 in the denominator. And can you see why it's so easy? The denominator is 100 in both of these ratios, which means X is 70. In other words, her balance increased 70%. Okay, now I've got one for you to try out. Here you go. Hit pause on the video. Hit play when you are ready to see the solution, but don't do it until you have solved it or at least given it a good try. We're just going to do the same thing again. Remember, we want to have the change over the original amount, and it's going to be equal to the percent. Let's use X to represent it, over 100. Okay, hit pause and go. Okay, the video's rolling, so that means you must have hit play, which means you must have given it a try. So let's look at this together. So David, during his first year as a librarian, earned a salary of $50,000. So that's his original starting salary. That's what he had his very first year. And now he makes more money. Now he gets, in his fifth year, $60,000. So that is the new amount. So how much did his salary change? Well, we need to subtract. Oops. Let me write down the right numbers here. 60,000 minus 50,000 is going to be 10,000. So his salary has increased by $10,000. That's going to be our numerator. 10,000 over which number? Which one do y'all think goes in the bottom? Yes, 50,000, because our original should be in the denominator. Good. Okay, now we're going to write X over 100. Whew, we have a lot of zeros on this one. We could actually simplify these fractions a little bit, couldn't we? I'm going to do that. Okay, guys, I simplified mine. I divided both the numerator and the denominator of my ratio on the left by 10,000. So 10,000 divided by 10,000 is 1, and 50,000 divided by 10,000 is 5. So that gives me an easier proportion to work with. Now I just have 1 over 5 equals X over 100. And this one, you know what? I can just look at relationships between these ratios. 5 times 20 is 100. And 1 times 20 is 20. X is 20. So what does that mean? We know that X is 20. Well, that means that David's salary increased by 20%. That's because our change was 10,000, and 10,000 is 20% of what we started with, the 50,000. Okay, now we're going to look at percent decrease, but we're actually going to use this exact same formula. So I'm going to copy and paste it down here because it's not changing. We still have our change divided by our original is equal to X over 100. Sorry, that's kind of off on the side there, y'all. Oh, well, that's okay. We can still work with it. So take a look, read this problem. It says an animal shelter cared for 400 dogs in 2012. In 2013, the shelter cared for 360 dogs. By what percent did the number of dogs at the shelter decrease from 2012 to 213? All right, I'm going to ask you to go ahead and pause this video because even though we haven't done a percent decrease together, I think you can probably do this one on your own. So pause it and give it a try. Okay, you've hit play again, so you must be ready to see how it's set up. And there's our proportion all set up and ready to go. So our change was 40. It decreased by 40 dogs, 40 less dogs. And the number we have in our denominator is 400 this time. It's the larger number this time because we started with a larger number. We have a decrease. Okay, so 40 over 400 equals X over 100. Let's see about simplifying this a little bit. I'm going to divide my numerator and my denominator by 10. Okay, 40 divided by 10 is 4. 400 divided by 10 is 40. And you know what? That wasn't the greatest common factor, so I could go even further, couldn't I? So let me take a look at what we can do now. We could divide both of them by 4. Okay, and now we're simplified. We have the proportion 1 over 10 equals X over 100. Let me kind of move this up over here. And take a look, what relationships do you see within these numbers that we have? There's definitely more than one way to solve it. This time I'm going to look within the ratios and say 1 times 10 is 10, and X times 10 is 100. So X must be 10 because 10 times 10 is 100. Okay, so X equals 10. What does that tell us? Well, it tells us that the number of dogs at the shelter decreased by 10%. So there we can write it down with a complete sentence. We have 10% less dogs in 2013. Here's one for you to try. And remember, we're going to use that same formula. We're still going to have the change over the original is equal to X over 100, or our percentage over 100. So take a look, hit pause, and hit play when you're ready to talk about it. All right, you've hit play, so you must be ready to go. We started with 120. That was our original amount. And now we have 60 cookies. She didn't sell as many cookies in August. That's our new amount. It's a pretty big decrease. What we want to know is what percent is that decrease. So our change is 120 minus 60. That's 60. Okay. The change over the original is 60 over 120, and we want to figure out what percentage that would be. I'm going to simplify this fraction again. 60 over 120 is the same thing as 1/2. And you guys are probably already thinking, oh, that's 50%, and you are right. So there was a 50% decrease in the number of cookies that Javier's grandmother sold. Her cookie sales decreased by 50%. Apparently people don't want cookies in August. All right, well, thank you. That is our formula for percent increase and decrease. It works similarly. Find the change, put the original in the denominator, and then write it as a proportion with the other ratio as X over 100.